Hi, welcome to the second video in this series. In the previous video, we were making a function to detect the Go programming language, and we did so by using some building blocks that were provided by spaCy. The function that we were built is shown here, and what you can see is that we loop over all the tokens in the document, check if the Go or Golang token that's been detected is not a verb. And if that's the case, then we figured we were pretty certain it's probably about the programming language as opposed to the verb. We benchmarked this code. We also saw some good coding habits. So we noticed that disabling the named entity recognition will make your spaCy model faster in this case. We also learned that using NLP.pipe is also a good habit. We built this decorator, we benchmarked it, and it was, at least to me, pretty obvious that we were onto something. Now, the idea of this video is to sort of expand where we were, to take our code base, and then maybe detect some other programming languages as well. It's pretty cool that we can detect Go, but for most use cases, I would be interested in being able to detect other languages as well. So I'll take this as a starting point. So once again, this is sort of the starting point that we had before. And what I'm just going to go ahead and do is confirm that this works. So has Go token, we give it that document. And in this particular case, it's looping over all the tokens. And this instance of Go is not a verb. So, you know, it should be able to detect this. And it works. And just as a naive way of thinking about it, one thing that I could be doing is I can just say, how about I just do Python in here as well? And that way, I should also be able to detect not just Go, but I should also be able to detect Python, the programming language. And with that thought in mind, I can also go ahead and add Ruby. And the reason why this is working right now is, and again, it's a bit naive, but the reason why this is working is because in my current corpus of the Stack Overflow dataset, I think all instances of Python and Ruby are going to be the language. So this sort of works, but I think that our current approach is getting a bit of an issue when I try to detect another programming language, like, for example, Objective-C. And to explain why this is going wrong, let's just make a small example to demonstrate this. So I could write something like, I am an iOS dev and I like to code in Objective-C. So if I were to run this now, it's going to say false. And the reason for that is that this document is looping over all the tokens in there, and then it's checking if a single token text, lowercase, matches this. But if I were to now just loop over all the tokens that are in there, you know, I am an objective, all that stuff's fine, but Objective and C and the dash there, these are three separate tokens. It's so this way of working is never going to work by merit of the fact that I'm not matching text in a single token. I sort of have to match over multiple tokens to find the thing that I'm interested in here. So as cool as the approach was we had before for just detecting Go, it's not going to be working for other programming languages just because there's multiple tokens involved. So we need to think about a different trick or a different way of thinking about this. So as luck would have it, though, the thing that we currently need, something that matches over multiple tokens, this is something that actually exists in spaCy. It's called a matcher. And in order to explain how it works, what I'm going to do is I'm first going to give you the interactive demo that you can find via the documentation page. It's a cool web app. I'll use that to explain how the matches work. And once I've done that, I'm going to go back to the document here and implement it here in actual code as well. So let's go to the documentation. So I've gone to the Explosion AI website. That's the website of the creators of spaCy. And when you go there, what you can do is there's lots of demos that you can explore. But the one that I'm currently interested in is the rule-based Matcher Explorer. So we're going to go ahead and click that, and then we're going to play with it. I'll clean this up such that there's a bit of a clean slate. I will remove the text that is over here. And what I'm just going to do is I'll just write in the text, I am a iOS dev, how do you spell iOS? Dev, who codes in Objective-C. All right, so now when I click refresh text, this is everything that you kind of need to see to get started. Now, the idea is that what you can do is I can click this add token button right here, and then something in the pattern here is going to appear, but also different stuff here gets selected. So what I'll just do is I'll click this add token button, and I'll do something like the lowercase of that token that needs to be iOS. And now when I refresh the text, you'll notice that iOS lights up. So that's the thing that's been detected, which is great. But now if I, again, were to type objective -C, and if I were to refresh that, that would not get detected. And again, you can click the show buttons token to confirm. The reason for that is that the objective-C in the dash part, that's in separate tokens. So I need to detect it another way. But the idea is that you can sort of make rules for multiple tokens that appear together in sequentiation. So these three that I have here, these are three representations of three different tokens. What I could do is I could say something like, hey, you know what? I have this objective thing, and then I have this C thing at the end of that. And then what I can have in the middle is something, I believe there was a thing. Yeah, so this is punctuation. And the way that I can sort of, and I do want that to be true, and then the way that you should read this is it's going to look for a pattern where there are three tokens. The lowercase text of the first token is going to be objective. The second token should be punctuation. And the token that then follows, it should be lowercase c. So now when I refresh the text, boom, objective C is matched. And when I turn the tokens off, you can actually quite clearly see that we're sort of detecting the thing that I might be interested in. Now, the whole reason why this works on Objective-C is because we can span multiple tokens. But the nice thing is that we can, by using this tool, we can sort of play around and then have some sort of a pattern here. And this pattern is something that we can go ahead and feed into the matcher object in our Jupyter Notebook. In general, when you're starting out with matchers, it is actually my advice to have a play with this this matcher demo. It's pretty nice that you can sort of fiddle around with all the buttons. So definitely give this a try if you haven't played with it yet. But for now, this is enough playtime for me. So I could go ahead and copy this pattern, which I will then use in the Jupyter Notebook from here. All right, so I'm back in the notebook, and what I can do now is I can just paste the pattern that we had before, and this is something that I'm going to be using. So what I need to do if I want to use the matcher object, one of the first things I got to do is make sure I've actually imported it. So I believe from spaCy.matcher, you can import the matcher object like so. And what you can then do is you can start a new matcher object. And what you got to do first, if I'm not mistaken, is you got to pass it the vocabulary of your natural language model. And what I will do is I'll just make a new matcher object like so. Now, the idea is a matcher object is an instance of something that matches, but we haven't done anything with the pattern yet. So what you can do is you can say matcher.add, and what this will do is this will allow you to add the pattern. Now, a pattern typically has like three parts. For starters, what it has a name. So in this case, I will say Objective-C, that's the name of the pattern I want to match. Next up, you typically give it a callback, which is not something I'm using right now, so I'll just put none in there. And then what you got to do is you got to put the pattern in there. So I believe this is enough for the matcher. And now what I could do is I can say, hey, matcher, like, could you maybe like take a document and see if you found any matches? So again, the document that we have is the IMA iOS dev and I like to code in Objective-C part. And what you can see is this matcher returns a list of tuples. And the first thing in the tuple is sort of like the match ID, if you will, which isn't terribly interesting to me at the moment. But the thing that I do find interesting are these two, because I believe this is the start and this is the end of the pattern that's being matched. And we can confirm this by just taking the document and saying, look, take the token at index 11 and go till the 14th one. And we check this. What comes out is actually Objective-C. So So just to recap, we have some sort of pattern, which is a list of dictionaries that describe tokens. And when we get this pattern and we give it to a matcher object, we can give it a name, we can do some nice things with it, but in essence, the thing that we can do is we can sort of do similar stuff as what we did before with our function, but we now have the power to span over multiple tokens, which greatly increases the flexibility of stuff that we can do. And one of the things that we could go ahead and do is we can sort of take this pattern and sort of make that a pattern for Objective-C. But we can also try and do is see if we can take the function that we had here earlier and turn that into a nice little matcher. Because it's not just sequential tokens, you can also make patterns to do single tokens. And this gives us a convenient API to make everything happen in these matchers, because I think we can also detect the Go tokens using a pattern. So I'll just rewrite this a little bit. So I'll just call this the Objective-C pattern, just to, keep things nice and clean, give it nice names. And what I can then do is I can say, well, there's a Golang pattern that I'm also going to be writing. And then what you could do below is I have this Objective-C pattern that I want to add to the matcher, but then I also have a Golang language that I want to add. And, I should do this a bit consistently, so if you're going to add multiple patterns, you should, make sure they've got the right names. But what I can do now is I can say, look, the lowercase text, that's got to be, and I think the syntax, if I'm not mistaken, is you can give it a dictionary, such that you can then say it has to be in a certain set. And what you can then do is you can say it has to be in a set of Go and or Golang. But that's not the only demand I have of that token. What I also demand it to be is that the part of speech, that should be not in the set of token. Yeah, so I think this is the only part of speech that I don't allow for now. Yeah, so I think this is a good starting point. I've got two patterns now, and what I'll just do is I'll put a document, make a new one here, and I'll do something like I am an iOS dev who codes in both Golang as well as Objective-C. Yeah, what you can see now is that's actually kind of nice. Is you can see that I can match over more than one pattern by doing this. I'm matching a couple of things here. So to make this a bit more explicit, what I'll just go ahead and do is I'll just I'll loop over this. So there's like a match ID, a start and an end, and then what I can do is I can say print. So let's take the document and let's print from start to end. That might be the nice thing to do. Yeah, so we can actually confirm here that by looping over all the stuff in this matcher, we actually detect both Golang as well as Objective-C. So this is nice. But what I kind of want to do now is I want to sort of clean up this code, maybe just a little bit. So what I will go ahead and do now is I will go to the documentation page of spaCy. Just to get a little bit inspired, see if there's any tips in there that allow me to clean up my code a bit. And what I will then do is I will clean up the code and also see if I can add some more patterns in different languages. And I'll start coding that up now. And due to the magic of time travel, you can see an intermediate result. So I've just cleaned up the code, even just a little bit, just to make sure we import our stuff and then we declare the rest. And I actually found like one small improvement even without looking at the documentation. So what I have done now, I basically figured, if the lowercase pattern, if the lowercase text is already Golang, that's not going to be a verb. I'm actually not as worried for that. So this can be like an easier thing to match. And then what I can also do is I can say, look, when it's actually Go, that's when I'm afraid that it's a verb. So then I kind of want to be explicit about that. And what's kind of nice about the matchers, and that's kind of why I wanted to show you this, What you can do also, like for a single matcher with this one, a matcher can have multiple sort of names attached to the stuff that it tries to match for. But what you can also do is you can add multiple patterns against one name that you're trying to find something for. So in this particular case, I have these two different patterns, but they are both good in detecting Golang. So I can add multiple patterns here. So I'm going to do a little bit more time traveling till I just add a couple more patterns in here. Okay, so I expanded the rules of the patterns a bit. And the main thing I've done is I've added one for Python, I've added one for Ruby, and I've added one for JavaScript. And you know, all of this stuff sort of works nice and as you would expect. And what I can do is I can invoke Python Go. I can sort of I can go ahead and add, you know, some text here, and stuff gets detected. But you do start noticing one weird thing here, and it's in this example, but it's also in this other example that I found. So let's also run this one. So we see that in this example, I am an iOS dev who codes in both Python, Go, Golang, and Objective-C. Go was not really detected. And there's another example below here where I can see that Go here is also not being detected appropriately. I kind of wonder why that's the case, but the easy way to verify that is to just iterate over all the tokens in the document and to show not just the token, but also the part of speech that's attached for that. And when you do that, you do notice that Go in this particular case is detected as a verb, and this is the natural language model in the background. So even though, you know, the pattern that we've described here is doing exactly everything like we describe it to, we should not be surprised that we're still going to miss sometimes, just because of the fact that machine learning isn't 100% perfect. So I would still say this is good progress. I can keep on adding programming language like this, but I should not be mistaken. Stuff like this will happen. So what I think will be nice now is I feel like this is something that's going in the right direction. So this is a good point in time to do some benchmarking. And again, due to the magic of time travel, I wrote a little bit of code here to sort of help me benchmark. And the idea is as follows. What I'm just going to be doing is in my original questions, I'll just look if the objective text is in there. And if objective is in there, but it's not matched by our matcher, you know, if I just do a quick iteration, just see some examples. And this is kind of a nice way quickly for me to get an impression of when am I not maybe detecting something that I should be detecting. And there's a bunch of examples here. And I actually see a couple of examples where I think I know what's going wrong too. So for starters, what I see here should maybe add a pattern when Objective-C is maybe all in one token. And another problem that I have here is that sometimes there's a dash in Objective-C, but sometimes there isn't. It seems that Stack Overflow people who ask questions aren't necessarily super systematic. And actually, I see lots of these examples going wrong. So this is something I feel like I should address. Yeah. So I think I see a nice fix for this. So what I can do is I can maybe do something with this pattern here. And one thing that you can do with this pattern is you can say, you know what, that pattern, this is punctuation thing in the middle, that can be optional. And the way that you sort of describe that is you do OP colon and then a question mark. But by setting the optionality in here, what I can specify is this has to occur, you know, 0 or 1 time. What you can also do is you can specify that it occurs any number of times. And if you're interested, I actually found this in the documentation. So if you go to the spaCy docs to usage and then rule-based matching, so I was doing a bit of reading on this, and then I actually found a part of the documentation where this is listed. If you scroll down, I believe a little bit further, but yeah, if you scroll down to here, there is this part about operators and quantifiers. So if you do a question mark, that will make the pattern optional by allowing it to match 0 or 1 times. Another useful feature is you can say, hey, that operator, that should not happen. And then you can say, I require it to match exactly 0 times. You can do something with a plus to say, hey, the pattern has to match one or more, or any number of times. But this is something that I can now use quite well in my notebook, because what I can say, hey, I've got this Objective-C pattern where the punctuation is now optional. So what I will do is I will say that's pattern 1, because I believe there was another issue as well where sometimes Objective-C was all one token, and I'll just make sure I've got that one as well. And what I'll do now is I'll make sure that I've got both this pattern as well as this one sort of in here. Yeah. Okay, so now when I run this, so the matcher gets a reset. So now when I use a different matcher, I can run the same benchmark and see if the results that come out are any different. Okay, so first of all, I'm seeing less stuff come back, which is a good thing. But also something that I notice, if I just take this as an example, I'm not yeah, so okay, so in this case I'm fine with the matching, but if I look at stuff like this, so if I give that to the NLP object, if I were then to say, hey, show me the tokens, yeah, so stuff like this, I'm actually fine with not detecting stuff like this, because the tokenizer is just having a hard time on how to sort of parse this properly. Maybe in a future video, I'll see if I can do something with the tokenizer such that it also detects stuff like this. But the stuff that I'm now not detecting is stuff like Objective-C++. I should check whether or not that's actually a different thing, but I'm actually okay with not detecting that. So I would argue that, yeah, we've made an improvement to the Objective-C pattern, which is kind of nice. What I could now do is also confirm this for all the other languages. But again, at a quick glance, what I'm seeing here is that stuff like Python path is not detected. And again, Python, the string is matched, but the matcher is not detecting this as the language Python, which I can live with. IPython, yeah, okay. So you know, maybe again, still for a couple of reasons, this is still not perfect, because again, NLP model behind the hood cap and all that. But once again, I would argue I'm onto something here. I've expanded what I had before, and spaCy's giving me the building blocks to you know, continue on doing the good thing. And yeah, it's not like all of my concerns are now gone, but again, I have the feeling that I'm trying to accomplish something, and yet again, I'm on to something. So I can continue on to this path that I'm walking right now. So that's a good feeling. I think I've made a very good milestone. So what I'll do now is I'll just wrap up. Okay, so where are we now? So we started today with a function for detecting Go heuristically, and we took this knowledge and we now have a very similar approach, but we're also able to deal with multi-token programming languages. And we're not detecting just Go. We've now found an approach that we can use to detect more than one programming language and still use some of the same building blocks as before. So today, in that sense, was a win. Just as a learning thing, like stuff you gotta keep doing, I think, is check the documentation for inspiration. I was really happy that I took the effort to read the documentation on matchers beforehand, because that showed me that some of these matchers, some of those tokens, they can be optional. And I would argue that kept my code really clean. I also think it's valid to point out that rewriting your code once you hit a milestone is also definitely a valid and a good idea. And again, I'm quite happy that once I think I've gotten something in nice code, that I have this voice in my head saying, hey, you should maybe check and do some benchmarks and see if your approach is valid, because you can often catch a couple of bugs quickly if you do it early. Again, I think I'm onto something, but there's some steps that I should probably do to formalize what I have right now. And what I kind of want to move towards is maybe, you know, we've got heuristics and they work, and that's great. But probably it will be nice to say if we can maybe benchmark this against like a proper machine learning model, to see how much of an improvement we actually make. And spaCy also allows for this. So what I'm going to do in the next video is I'll take some formal steps that I need to do towards the path of making my own actual language named entity recognition model. And I hope to see you in a future video for that. Have a good one.